Hey, welcome back. In this video, we are going to learn about logistic regression. So, logistic regression is used for binary classification problem. And the output is in 0 or 1. So, maybe we'll take an example of one exam result kind of thing where a student is studying for a few hours, and based on the hours, we are predicting whether the student will pass or fail. All right, let's say the student has studied for 8 hours and he passed, and if he studied for 2 or 4 hours, then he failed. All right, so this is the cases. Definitely we can create our own data. We can take data from some actual exam results based on that, but for now, like in this lesson, I'm going to create random data. All right, let's start. So I have created one notebook from on Google Colab. So I'm gonna name it Logistic Regression Model. Alright, so I'm going to import a couple of things which I will be needing here. Import torch.inn as in. Okay. Alright, so these two things I will need here, and apart from this, what I was thinking, like let's import everything here. What I will be needing. So although like I can import it later as well, but let's do it right away. Matplotlib for okay. These are the two four major things which we also used in last video in linear regression model. In this video, I'm also going to use all these four imports. Okay, now the first step is to generate our data. Okay, so let's comment it out. Generating synthetic data. Okay, so what will be our problem? So the problem statement is will create a synthetic data set where okay, so where the goal is to predict if a student actually passes an exam based on the number of hours studied. Okay, is it clear? Okay, let's do okay, let's create some data set here, and then we'll proceed further. We'll plot the data set as well, and we'll see like how it looks on the graph. Okay, the first thing is like we need to create an input data set. So I will take some random number 100 to 1, and then what I'm gonna do here is I'm gonna put tab x. Okay, so it's giving me like some number between 1 to 10. Before I create y value, what I'm gonna do here is I'm gonna use some manual seed. The reason behind that is whenever no matter how many times I run this, the value will be same. Okay, and for y what I can do here is I need something for this value it may be 1, for this value it will be 0, for 1 it means like the student couldn't pass, and for 7 it actually cleared the exam. Okay, so let me do some logic here. If x is greater than 5, probably 6, and so right now if I just show you what y looks like, so here it is in true and false, but I need value in 0 and 1. So what I can do is I can use float method, and then the y will have values like 0, 1, 1, 2 and those things. Okay, so now we have the data. The next thing what we are going to do, plot input, plot dataset. Okay, so for to plot I will use matplotlib, scatter x and y, and plt dot x label. Okay, it's giving me the hint and I will be using the hint. Okay, so now x level and y level, and I can also use title. Let me check the title as well. Title, I don't know, what should I give? Hours versus exam results, something like that. Okay. Okay, now it's, as you see, for those students who studied for like these many of hours, around 5, they cleared. I mean, they actually couldn't pass the exam. And for those who studied for around I mean from 5 to 10 hours, they cleared the exam. Okay, so it's pretty much clear from this graph our data, I mean how our data looks like. Now what we will do is we'll create our model. So let's create a class, logistic regression model. As we did in last video, we are going to inherit it from nn.module, which is our base class for all the models. Now I'm going to create constructor self, and I will need 2 things as well: in features, out features. I'm doing a lot of typos. It's happening frequently. Okay, fine. Again, do super. Alright, so as you see, like I'm using the same thing as we did it previously in the linear regression. So nn.linear model, what it will do is like it will accept number of input features and output features. Based on output features, it will create a neuron. Let's say it has, I'm passing 2 here, then it actually it needs to show 2 outputs, so it will require 2 neurons. For in features, if I'm passing 2, then the 2 input will be passed to all the neurons. But right now I'll be using 1 and 1, and this will create something like a linear equation: y equal to w star x plus b. Okay. Here in forward method, I'm using sigmoid activation function, and this part is actually predicting the value. So this is a forward pass. Okay, we call it forward pass. So we are passing x value in forward and getting the prediction out of it. And with the help of prediction, since we need some values in between 0 to 1, since we are working on probability, so what will happen is like it will give us a value from 0 to 1, and based on that probability we can determine whether the final output will be 1 or 0. So what is sigmoid? If I show you sigmoid graphs, then you can see, okay, so this is the equation of sigmoid. Let me just open it in new tab. This is the equation of sigmoid function here, and its value falls between 0 and 1. All the x can happen like negative numbers and y, I mean positive and negative numbers, but y will fall between 0 and 1. Okay, so that will provide us a probability of something happening. Okay, so this is the same as we did in linear regression model, but here we are using an activation function. Okay, so our model, we have created our model. Now it's time to use initialize lies model, loss function, loss, as well as optimizer. Optimizer, sorry, optimizer. All right. So next we can do is like we can create an instance of model, logistic regression. Okay. So here in loss function, I will name it loss. I'm using binary cross entropy loss. Okay, so for those who are not aware what is binary cross entropy loss, so basically we use this in classification problems. So if I show you the formula of this based on the prediction, like between 0 to 1 value, the loss is going to calculate uh, the value with the help of this formula. Although I can explain it in depth, but let me just show the formula first. Okay, so here what will happen, I believe it's y star log y hat. How I can put y hat? Y hat is the prediction. Yeah, I can use this way, as well as plus y1 minus y, and we can use log 1 minus y hat. Okay, so this is the formula for binary cross entropy loss. So it will calculate the loss based on this formula. Then what is going to happen will actually this is an instance of binary cross entropy, and we will be passing y prediction and y as we did it in mean square error as well. And in optimizer, what optimizer will do based on this learning rate, it will start updating the weights and bias. Okay, so that we'll see. Okay, now what we are going to do, we are going to create two variables, one for the epochs, let's say 1000 epochs, and for the losses I'm going to put an empty array. The reason behind that is for each iteration we can append here. All right, so I'm going to create one loop epoch in range will provide us a series from 0 to the epochs number of times, the 1000. Okay, and now the first thing is we need to prediction. And if we try to predict, what will happen is how we can type y dot prediction, that is we'll be using model, and we can pass x. So what is happening here, so when we are doing this, we are actually doing forward pass, and the forward pass is actually getting the value, getting the prediction based on the random weight and bias. It will provide us y prediction. Okay, for the initially it will be a random number, then later we will be optimizing w and b once we calculate. Now the next thing is calculating loss. Okay, so we created an instance of loss here, binary cross entropy loss. Now it's time to actually, or let's keep it loss function so that it will be more clear. So loss function, here I can pass y prediction, y actual true value, and I can just take this loss output. Okay, now we have the loss. Now what we can do is we can calculate the gradient. It's giving me a good comment as well. Calculate gradient. So when we will when we will go backward, it will start calculating the gradient. Okay, and so all the weights gradients. So for this equation, maybe like if we have multiple hidden layers, then this might be an output of different neurons. So here it can be some other expression. If we calculate, it can be a huge, too many parameters here, and based on all the parameters it will calculate gradients. Okay, and the next thing is update weight. Okay, so here we are updating weight and then we are resetting gradient. So optimizer will update weight according to the loss. So if you're not aware, the formula which works here is like W minus W uh, star, actually learning rate, LR star DL by DW. It's W is not just for parameter. I don't know what you want to use. Maybe it will be W for this, and we will also calculate gradient for this. So based on, like, if we are using W, then it will be W. If we are using adjusting bias, then it will be okay this way. Now this will reset the grad, since it keeps the data inside dot grad. Optimizer keeps all the gradients inside dot grad, but we don't want to have the same thing in the next iteration. That's why we are resetting it. And as it was giving a suggestion, it was giving a suggestion, right? Okay, I forgot to append the loss. I can do it later as well. Okay, here uh, update total loss. Here what we can do is losses dot append loss dot item. Now display epochs versus loss log. Okay, fine. So now what we can do is, if I going to print for each iteration, there will be thousands of lines. So I don't want that. So it will be unnecessary. So I'm just going to divide it by 100 and see whether the reminder, if there's any reminder, and then based on that, if it is 0, then we can print. For the epoch, I just want to modify a bit here. I want to show total epochs here. And let's do one thing, put it 1 here, so that it will start from 1. Okay, I'm getting some error. I didn't run this again, I guess. That's why it's happening. Now, as you can see, we started from this much of loss and it ended up here. Okay, I would like to do few modification here. First, I don't want to show this much of this many digits. Instead, till 4 is fine. So what I can do, I can convert it to 4 digit after decimal, and I was trying to do, I want to increase this epoch. Let's run this again, this again, and this again. And now you see it raised to 2308. Let's plot the graph. Okay, so now we are going to plot the graph with torch dot inference mode. It is same as no grad. So where we are not using gradient feature, when we will be predicting it, it won't consider the gradient actually. So the calculation will be, since we are just predicting it, y prediction model x and predicted value of, so this is actually predicted value, but what is happening here is let me show you first. Y predict Okay, it won't print actually inside this context. It won't print. It's inside this container. It won't print. So let me just go out, get out from here, in this from this context and try to print it. Okay. Now you see the predicted values in between 0 to 1, but okay, but I need in either 0 or 1, right? So for that, what I can do is I can get the predicted y dot, I'm going to round it. This time if I try to log it, what will happen in that case? Now it is coming 0 and 1. Okay, fine. Now we want to calculate accuracy, but for that what I can do is I can follow this thing as well, but there's another way to follow. So let's say predicted equal y. Y is the true value, right? And this will provide us a matrix where true false comes, but I need to actually convert it, right? Actually sum those numbers, and if I do the sum, I can get like how many are true and how many are false, and then I can just get the value out of it. Okay, I don't know if it is clear. So maybe I can show you step by step. Try to print this accuracy. Okay, so now the total sum is 97 for those which are equal to y. I mean the 97 values are actually correct. Okay, 97 values are actually correct. So in that case, accuracy looks very good. And if I take out, okay, if I just use item, so I can get the float value, and then I can just divide it. Okay, I don't want 180 a tensor, that's why I'm using dot item. Okay, so the y has length of 100, so it is giving us 0.97 accuracy. Okay, now the thing is uh, what we can do is like we can display it in percentage as well. So for that, print f accuracy, and not this way. What I'm gonna do is I'm gonna use accuracy star 100, okay, and 2f. In case if it is in I mean in case if it is in decimal, then in it will show only two numbers after decimal places. Okay, let's do it. 97.04. Great. Let's plot this graph. For plotting the graph, I mean the plotting the losses, if we want to plot the losses, then what will happen? How we can display the loss? plt.plot losses, but on x-axis we want to display epochs, so I will need range epochs. For y-axis I need it is already a series, so what else I can type here? Okay, let's type it separately. X level, and here x level Here what I can use is epochs plt.y layer. Let's use it as loss, and plt.title, use it as mm, losses, loss per loss. Okay, loss versus epoch. That's fine. Something like that. That you can definitely modify. That doesn't matter. Now I want to run this. Okay, so I want to run this and see if everything is fine. So as you see, this is giving us, I mean, a loss epochs graph, and if you notice here, it started from here. I mean, the loss was very high point, around 0.8, and then it suddenly dropped to 0.45 or somewhere, and it gradually dropping it here to 0.2 and something, right after 2000 epochs. So if